Let's have a look at this question. It says the area of a quadrilateral bounded by y-axis and the line x equals to 5 and the line lines this. Now, this is an interesting question to understand. If you look at the graph, what they're talking about is y-axis, which is very easy to draw. So if you look at your y-axis over here and you are looking at another line x equals to 5. So if it is the area bounded by a quadrilateral, it has to be between y-axis and x equals to 5. Now let me say that x equals to 5 is somewhere a line on this, which is your x equals to 5 like this. Okay. Now, what we are more concerned with is just what is happening in between these two lines, which is your y-axis and x equals to 5. Nothing else we are concerned with, right? So we have to evaluate this third line over here between the regions x0 to 5, because anything on this side will ensure that it is not bounded by x equals to 5. Anything on this side will ensure that it is not bounded by y-axis. So what is happening in between these two lines is what we need to look at. That means it is x lying between 0 to 5 is what we are concerned with. And the only line that is yet to be evaluated is mode of x minus y minus of modulus of x minus 5 is equals to 2. This is what we need to evaluate. Now, one thing is very clear, that x lies between 0 to 5, then x minus 5 must be negative, right? So let me just simplify this. Mode of x minus y is equals to 2 plus modulus of x minus 5 over here. And we now know that x lies between 0 to 5. That means x is less than 5. I can drop the modulus around x minus 5 by multiplying it by a minus 1. So what am I going to get? 2 plus of 5 minus of x. That should be equals to modulus of x minus of y. Now, what am I getting? Modulus of x minus y is equals to 7 minus of x. Now, this is what I need to evaluate. Now, there are two ways if I want to remove this modulus. X minus y should be equals to 7 minus x if x is less than 7 in that case, because it has to be positive on the other side. Or you are looking at x minus y is equals to minus 7 plus of x. These are the two split ups that we will have to evaluate. If you look at this further, you are going to get 2x minus of y equals to 7 is one line. And what is the second line that you are going to get? X will get cancelled out. You will have minus y equals to minus 7 and y will be equals to 7. So you are evaluating y equal to 7 as a line over here. Now, if I have to evaluate y equals to 7 as a line, this is a line that somewhere moves like this. This is your y equals to 7 line, right? So I'm putting this over here, y equals to 7. Now comes the next line that we need to evaluate, 2x minus y equals to 7. Now, I need 2 points in order to ensure that I can generate a line. So I can simply put y equals to 0 in this. If I put y is equals to 0 in this, x will become equals to 7 by 2, which is going to be 3.5. Correct? Or if I put x as 0 in this, if I'm going to put x as 0 in this, then I'm going to get the value of y as minus 7. That means these are the 2 points where the line is intersecting with the x-axis and y-axis. Okay. So y is 0, x is 3.5. That means a line somewhere, a point somewhere over here. Right? And x is 0 and y is equals to minus 7. That means a point somewhere over here. If I join these 2 points, I'm going to get a line. Now, the problem with this is that I yet don't know where is this line going to intersect with x equals to 5, right? Because I can join these 2 points, but is it intersecting above y equals to 7 or is it intersecting lower than y equal to 7? Where is it intersecting is important for me to know. And hence I'm going to put in this particular line x equals to 5 also. If you put x equals to 5 in this, what are you going to get? 10 minus of y is equals to 7. That means y will turn out to be 3. That means it is going to intersect lower, right? So now these are the 3 points that I have, and I can join these 3 points with a straight line, and I'm going to get my region. This is what we are getting. Now, what is the intersection point over here? X was 5 definitely, and y was turning out to be 3. So 5, 3 is a point that we have over here, right? Now, we need this area bounded by y-axis, y equals to 7. This line over here, which was 2x minus y equals to 7, and x equals to 5. So what are we looking at? We are looking at a trapezium. You can do it by using the formula of trapezium, or you can create a triangle for yourself, which is this triangle, and then a rectangle is available for you to evaluate, right? This point on the y-axis is 3. This point over here was minus 7. So if you look at from here to here, this length is going to be 10 units. This length from here to here is going to be 5 units, right? So what is the area of triangle? Half base into height, which is 5 into 10, which is going to be 25, plus the area of this rectangle that we are looking at. What will be the area of this rectangle? This height, because this was the variable, this was the intersection which was at 3. So, and this is at y equals to 7. So this height will be 4. And what about this? This is going to be 5. So you will have 5 into 4, 20 as the area of that rectangle. So total, if you look at it, it is going to be 25. Sorry, 5 into 4, that's going to be 20. And then 25 plus 20, that is going to get you 45 as your answer. So 45 square units will be the answer to this question.